welcome to our lecture. And, well, I will leave the honors of introduction to the Consul General of Italy, Enrico Pavone, and also Rolando Del Maestro.
Thank you. Good afternoon to everybody. It is, of course, a great honor to be here today at the Osler Library of the History of Medicine, surrounded by scholars, students, and enthusiasts of history and science. I'm so sorry that I have missed the tour of the library, but since we are not far from here, I hope I will have another opportunity to visit and to look at the beauties that are here kept for everybody to benefit. First and foremost, I would like to extend my congratulations, of course, to the organizers of this conference, McGill University, the Osler Library, and the Montreal Neurological Institute and Hospital. I also wish to underline the contribution of the Italian Cultural Institute in Montreal, the scientific advisor of the Italian Embassy in Ottawa, our colleague Costanza Conti, and to the Italian Ministry of Foreign Affairs and International Cooperation in supporting this event. We are privileged today to welcome Professor Alessandro De Angelis, an esteemed physicist and astrophysicist, whose contribution to academic research have gained international recognition. His work at institutions such as the University of Padua and the University of Lisbon, as well as his role as a scientific advisor to the Italian delegation to the OECD in Paris, underscore the significance of Italian excellence in the global academic and scientific landscape. Today's conference delves into the broader themes of scientific evolution and transformative impact of intellectual exchange during the Renaissance. Thanks to Professor De Angelis, we will examine how the pursuit of knowledge, open dialogue, and collaboration across disciplines laid the groundwork for the modern scientific progress. This event can serve as a platform to reflect on the relevance of this principle in today's academic and research communities. We will dwell on the achievement of Galileo Galilei and his engagement with other scholars, including Johannes Kepler, demonstrating how collaboration and debate fueled groundbreaking discoveries in the centuries. Galileo's discoveries were not made, of course, in isolation. His exchanges with Kepler highlight the blend of competition and cooperation that fueled scientific progress. Their dialogue exemplifies how knowledge transcends borders, advancing human understanding. Reflecting on this history, we recognize the value of international academic exchange. Scholars like Professor De Angelis, like Professor Del Maestro, continue Italy's and Canada's tradition of scientific excellence, strengthening global collaboration in science and education. I'm convinced that today's discussion will inspire many of us and will let us appreciate not only the legacy of Galileo and Kepler, but also the ongoing impact of scientific inquiry in shaping our world. Thank you very much for your attention, and thank you again for being here. Grazie mille.
Thank you very much, everyone, for coming. I can tell you what, it's an amazing privilege for me to have Dr. Alessandro De Angelis here. On Tuesday evening, my wife and I were in Waterloo at the Perimeter Institute, and the Galileo exhibition was held there. And what I can tell you is that there was a large number of individuals there, and a number of very interesting different types of talks and lectures and even music, etc. But I think everybody was actually thrilled to hear Dr. De Angelis's comments related to Galileo, and Galileo particularly related to localization and how he worked associated with that. And I think today we had the privilege of having Dr. De Angelis in the Ulster Library, and we have a large collection of Galileo's work, of Kepler's work, and particularly many, many manuscripts that are absolutely unique in the world. And he can talk about some of these manuscripts if he likes, and we obviously would like to work together with him. And so the manuscripts can be more studied and brought out even further, and make the Ulster Library an important part of this continuum of interests and historical aspects of the Renaissance in particular. So with those words, I would like very much to ask Dr. De Angelis to come up and to give us his presentation. But I also would like to thank Constantine Conti and everybody else who has been involved in that, and especially to thank Svetlana, who has helped put this together. So Dr. De Angelis, thank you very much for coming. It's been a pleasure to be associated with you and to know you. First, we only knew each other by email, but now we know each other in person, and that's much, much better. Dr. De Angelis.
Mesdames et messieurs, chers amis, merci pour le privilège d'être ici. J'ai passé une très belle journée et vraiment je ne m'attendais pas à une expérience comme celle-ci. Je trouve que celle-ci, c'est une des plus belles bibliothèques parmi les dimensions de cette bibliothèque que j'ai jamais visitée dans ma vie. Et c'est une très riche bibliothèque. Grazie al signor Console Generale, grazie a Costanza. And now I will speak English. Okay. I want to start with something, I will discuss about Galileo in his times, and I will try to tell some funny stories related to libraries. One story that I like a lot, that could be a subject for a dinner talk also. But I want to dedicate this lecture to a friend of mine who is still alive and well, who is one of the two best experts of Galileo, living experts of Galileo, which is Bill Shea. He had the chair of History of Science in Oxford, and then he got the Galileo Galilei chair in science, general science in Padua. And he's Canadian, he's Bill Shea. And if you invite Bill, who is one of the most eclectic persons with, a culture that surprises me, and then a culture that has the freshness of the new world coupled with the culture that he acquired as a professor in Oxford. He's one of the most pleasant guys. So, to Bill, and I will show him the movie about this talk, and I'm sure that he will be happy. Okay, so shortly before, so I will talk about Galileo Galilei, especially the Paduan period, what he did in connection with other countries, other cultures, and how his interaction impacted his work. I will have to select just a few topics because this could be a full course of history of science. Actually, Bill was made a full course on this topic. So Galileo was born in Pisa in an exceptional time in which the Italian Renaissance was revolutioning several fields of culture, and Galileo could live intensely all these fields of culture. He made classical studies, but also mathematics. At those times, the classical studies were not separated from mathematics like they are now. His father was a famous musician, but he was not very rich. But the family was somehow wealthy because it was a family of medical doctors. So somehow the father of Galileo thought, I want my son to become a medical doctor, which is very frequent. So also in Italy now, the fathers want the children to be medical doctors or lawyers. This is but Galileo didn't want. So he was sent to study medicine, but he never graduated because he was studying mathematics. This was his passion. When he was a kid, he saw a supernova. A supernova is a fantastic event. It is an exploding star. So you have for 1 year a new object that is more luminous than all the planets Actually, after the Galileo death, we didn't have any galactic supernova, and I mean, this is quite anomalous. It is a very unlucky fluctuation. Now we could do incredible things. If we saw supernova, all the detectors of different particles would make some deductions, some inductions about physical reality that are priceless. The careers of the young would be boosted by such an event. But just nature is not so generous with us. Okay, Galileo didn't have an easy character, especially as a student. He wrote when he went to Padua. He was very good at mathematics. So being good at mathematics is an ability that you understand immediately, and it is highly appreciated and recognized by the others. It's like music and so. So if I see a student who fills a blackboard in the right way, I can immediately say, okay, this guy has it as the factor. And Galileo was very good. So even if he was not graduated, he was hired as an assistant lecturer in mathematics with a low grade. Still, he was not an easy character, and in particular, he wrote a poem against the full professors, which is he was also liking poetry and painting. So his poem about full professor is also quite vulgar, saying that I don't know if I can use all the words or not, if they are from Galileo. So they were saying that the full professor is basically some flasks full of piss, and this was in his poems like this. So, but the consequence of this was, maybe partly because of this, I mean, his contract was not renewed. And so he had to find another job. And he immediately applied for a full professorship in Bologna, but he lied a bit in his CV, and he was not selected. And then he applied in Padua, and he got the job. By the way, we have still in Padua, in our archive, some of the papers of the selection committee. So they had some candidates like Giordano Bruno. So they had a lot of problematic candidates for this full professorship. So Galileo got it. So Galileo arrives in Padua in 1592. He is 28. He gets a reasonable salary for the age. The town has 40,000 inhabitants. This is a map of the town. The town is still quite more or less the same. I mean, actually, only in the 1950s they made major changes in the center. Before 1950, it was preserved as it is in this map. Okay, of course, now outside of the walls, I mean, outside the walls there were just grass. Now, outside the walls there are most of the people, but still the inhabitants in the center are the same number. And just before, a lot of inhabitants in the center were students, professors, and normal people. Now they are banks and things, and people a bit more wealthy. Padua was the university of the foreigners, because it didn't ask for profession of faith. So even if you were not Catholic, you could study in Padua. In Bologna, that was the other big university, they were asking to declare that you were Catholic. And the schools of medicine and law were very, very good. Like, for example, William Harvey came in these days. By the way, William Harvey, his parents wanted him to graduate in law, but he wanted to study medicine. And in the end, he made a deal that he would study medicine and law. So he graduated in the same time in medicine and law. And he's the only guy. In Padua, we have in the central place of the university, which is called the Bo. Until the year 1600, we have the symbols of the families of all the people who graduated. And William Harvey has two symbols. He's the only guy who has 2 degrees recorded by it. Okay, if you come to Padua, if you come to Padua, I'll be happy to show you. And because another funny thing is that at the time there was a University of Ferrara that was a bit easier than Padua. It still is. So many people who couldn't graduate in Padua, they were going to Ferrara to graduate. I'm sorry, I know that there is one person from Ferrara here, but this was the fact. And one guy that didn't graduate in Padua and he had to go to Ferrara was Copernicus. So this means that we were wrong. I told always to my colleagues that if Copernicus couldn't graduate in Padua and went to Ferrara, they were right. And so in the end, after the success of Copernicus, they made a fake graduation symbol for Copernicus in Padua to say Copernicus graduated in Padua, but this is not true. Okay, fine. So Padua was rich, a lot of libraries, a lot of foreign peoples, and the teachers were coming from all around the world. Why Padua was rich? Padua was rich because it was the University of Venice, and Venice was very rich. And Venice had 200,000 inhabitants, so 5 times more than Padua. Now they reduced by a factor of 5, so Venice now is 40,000 inhabitants. They had an advanced postal system. Galileo and his brother, who was a musician of the court of Bavaria in Munich, were exchanging letters. And a letter from Padua to Munich was taking 5 days, like now. I mean, the same number of days. It had top publishers, 400 publishers in Venice, so many books are published in Venice. They were discovering Greek books that were thought to be lost. They were discovering and publishing for the first time things like the Rerum Natura. And now, still half of the titles published in Venice are in Biblioteca Marciana, one of the national libraries of Italy. Italy has, I think, 5 national libraries. If I'm wrong, correct me, from the Institute of Culture. And one is Marciana in Venice, which is fantastic. And one central national library in Italy, which is not in Rome, but it happens to be in Florence. Okay, so in addition, the Venetians redesigned the Po River, the biggest river of Italy. The main authority of Venezia was the Doge, the Duke, let's say. And at the same level of the Doge, it was the master of the waters. So the power of the guy controlling the lagoon of Venice was like the power of the Doge. He had the right to say no to the Doge, because the delicate equilibrium of Venice had to be preserved. Still, you could see the first signs of the decadence of Venice in the fact that the plague had damaged a lot the town. And then the church was extending its influence to Venice. And in the period of Galileo, there was the famous condemnation of Giordano Bruno. Giordano Bruno was betrayed by the Venetians. There was Campanella's torture. But Campanella was also in Padua because they wanted to open a religious university in Padua. They didn't succeed doing this, but Campanella was making some courses for expanding the church. And then the leader of the Venetian church, Paolo Sarpi, was a medical doctor and a physicist, and a guy of deep culture, was victim of a murder attempt in which they put a knife in his eye. And he was lucky enough that one of the most famous doctors of Padua of those times, I don't remember his name, but it is the guy who made the first measurement of the basic metabolism, Santorius Santorus was living close to him, so he could heal him. So Paolo Sarpi survived to this murder attempt, thanks to a good doctor. Okay, so in the end, Paolo Sarpi emigrated to Holland, and Paolo Sarpi was famous for his jokes, and after this murder attempt, he said, "Agnosco stilum Romane curie," which means I recognize the knife or the Church of Rome, or the style of the Church of Rome, because in Latin they use the same word, so he didn't lose his sense of humor. Okay, this was Venice in the time of Galileo, and it's also quite similar to now. And on the top right, you see the arsenal. The arsenal, to me, was one of the most impressive things of Venice. It is the real center of the power of Venice. Dante Alighieri speaks a lot about the arsenal. You know that Dante Alighieri, even if he was from Tuscany, spent much time in Veneto. And actually the Inferno was written in Veneto. I say this to the Tuscany people, that I'm from Veneto. Okay, so the young Galileo arrives in Padua, and he meets relevant people. Thanks to Venice, he enters in the milieu of the culture of Europe of that time. So he becomes a star. Still, he's not publishing. I mean, his reputation is based on just on contacts and on small papers and things like this. He meets a woman. He doesn't marry her, but he has 2 children, and the 3 children, 2 daughters and a son with her. He has quite an adventurous life, and compromising a bit his health. He doesn't live with his family. He rents an apartment for his family, and he lives alone with a technician and some students. For example, William Harvey will be a guest of his home. The best students. So some of the best students discuss with him. He has ideas. He realizes instruments. There is a book here about the compasso, that is a computer, that he realizes in several hundreds of copies that he sells. And he has friendship with many colleagues, some from Italy, some from outside Italy. Italy was not existing as a political entity yet, but it was existing as a cultural entity. Galileo defines himself as curious by nature. And if you read his books, this curiosity is evident. And he says that this curiosity made him to spend a lot of time in the arsenal of Venice. At the time of Galileo, you had 2 public transportation from Padua to Venice every day. And public transportation was taking 5 hours. Now you have 3 per hour, and it takes 25 minutes. So, but Galileo was going very frequently to Venice and looking to the workers and learning from the workers, especially from the, I don't know the English word, the foreman, from the foreman. And here he invented the experimental physics. So the Paduan period is most known for the invention of experimental physics that he didn't publish. There is just an apocryphal book taken by his students. By the way, a copy is here, and published before the death of Galileo, so you can see this book. I don't know if it is digitized. Okay. So Galileo does all this. By the way, the book is full of errors that we think are due to his students taking the notes. Why do we think this? Well, because I'm a professor, and when I make a mistake and the students tell me, why did you say this? I say, you made a mistake for sure. Okay, so maybe he made some mistakes as well. And in Padua, when in Padua and Venice, he does a thing. I will just talk about one theorem, because I mean, theorem to me is one of the best expression of human ingenuity and creativity. A theorem is forever. It's not like the diamond will become iron with time. If you wait long enough, everything becomes iron, which is not nice. But a theorem is forever. So the best theorem of Galileo is, according to him, was done in Padua. The theorem says this: take a circle and imagine an object to fall along a chord. So all the time of fall along every chord will be the same. So you have a big imagine to have, you have a circle as high as this room, and then you just make the small chord, so the time is the same. Difficult to believe, but true. How do I know that it is true? Because I redid the demonstration, so I believe it. Then a corollary even more incredible is that if you take a chord and then two chords, the movement along the two chords is faster than the movement along the single chord. This is unbelievable, but true, because it's a theorem. Everybody can do the demonstration. I did. And then he made another corollary, that is that the shortest time to make a path is along the circumference, and this was wrong. So Galileo sometimes was wrong. And then he made some other more, some other conclusion. But just to tell you, incredible demonstration by Galileo. Okay, then Galileo was, like Leonardo, was extending the capability of his mathematical, the power of his mathematical tools to completely different fields. Like, for example, he studied, when in the Arsenal of Venice, the relationship between the size and the strength of a structure. And he made some assumptions that are still quite reasonable, and they were just updated 1 century ago, about the relationship between why the physical structure of giants is different from the physical structure of little people, small people, and so on. But then his fantasy was incredible, because in the end, he also wrote, but he didn't publish in his book, he just wrote in his notes. Galileo has more than 200 notebooks. He was writing a lot, he was writing really a lot. So he wrote also a comment on why he thinks that women go more frequently to toilet, still related to the relationship between size and strength. So he made he had a lot of fantasy. Okay. And then he made a lot of, this is a nice story, because his father, many of us, I don't know if it's true for boys and for girls, but it is true for boys, I know, have a kind of complex against the previous males of the family. Somehow. And also Galileo had. So somehow his father wrote a treatise about harmony. So why some music is, we like some music, we don't like some other music. Of course, at the time, people didn't think that this is a function of civilization and of time. So Galileo said, since the father of Galileo wrote a book in which he was talking about Pythagoras and the relationship between harmony and consonance, he wrote also some physical explanation of how the correlation, come si dice, the relationship between commensurability, this was the word that I missed, of wavelength was related to how pleasant were consonances. Okay, this is just an exercise that shows that Galileo culture was wide. By the way, Galileo was also a player of lute, and actually he said that I can play any instrument. What does it mean I can play? So he was a polyinstrumentist. But he said also that he was not as good as his brother. So, what is the main heritage of the period of Galileo in Padua? It is probably the scientific method. The idea that you observe nature, then you make an inference, an induction, and you induce a truth. And then you use this truth to make a deduction. And then you compare the result of deduction with the observation. So this is the principle of what Galileo says. And he says it quite easily. And so in his mind, mathematics was a branch of physics, which was not the case always at those times. For some schools, mathematics was the basis of everything. But in the scientific concept of Galileo, there is a bigger reality. Of course, you can think that there is even a bigger reality, like metaphysics. Okay, but Galileo just limited the description to physics, which included mathematics. It was the language of physics, of nature. So this is a very funny example of Galileo mentality that I like a lot. And this was commented by many people. And as you know, Galileo was writing many papers, the best 2 books of Galileo written, no, 2 of the best 3 books of Galileo written in the form of dialogues. Dialogues is great because, first of all, you can express some demonstration that you're not sure of as intervention to the dialogue. So suppose that I'm sure of something, I make 3 people, you, me. So one is the guy knowing the truth. One is the guy who has some intuition and some ingenuity, and the other is the moderator who asks things. So this is the typical style of Galileo. Normally the moderator was a bit stupid. Okay. It also had a name that was a bit evoking the idea of stupid. It was Simplicius, the moderator. Okay, so you have the 2 guys, and then, so one guy was saying demonstrated things. The other was saying things that were 90% true, 10% false, but of course this way you can extend your power, because one limit of mathematics is that if you are slightly wrong, you are wrong. But with the dialogue, the guy who is slightly wrong is somehow right. So this was a trick. So now, please pay attention to this problem. So you take a scale, a balance. So on the left, you have a saw with some water. On the right, you have a brick, and they are in equilibrium. Now, under the saw, you have another saw. Now you open a hole in the upper saw, and then the water starts falling. What will happen? So Galileo poses this problem, and then the 3 people start discussing about this problem. Galileo doesn't know the answer. The answer is very difficult. Okay? To solve this problem, you have to make some differential equations that Galileo didn't manage. Of course, you can think, okay, I think the first conjecture of Galileo was that, this is a translation words of Galileo, in the beginning, the water falling is in the air, so doesn't weigh it. But then it falls on the lower saw, and then the percussion gives an extra strength. But you can think to many other different things for the solution of the problem. Are there any physicists here? No. Okay. Let's see what you think. I tell you that I'm also a physicist. I got it wrong. What does Galileo do? He builds a machine. I mean, in the end, he cannot go find a solution. He says, okay, let's make the apparatus and solve the problem. Okay, this was an example of Galileo times. Of course, he was living with a technician, so he could build machines very easy. He was saying to the technician, do the machine. Okay. Fine. Galileo, like the young Newton, was not using real mathematics, but he was using geometry, which gives a different way of thinking. For example, Newton was using geometry when he was young, and then he moved to mathematics. The French school was using mathematics. So Newton was mastering both languages. And I mean, if you read the books of okay, now I say something in let's say, a coded message for the people who study mathematics or physics. So when there is a difficult problem that is the integration of the parabola, how to compute the area below a parabola. This problem was solved by Archimedes, who approximated the parabola as a sum of triangles. And then Galileo makes the same problem. Galileo had 600 books, a lot for those times, 2 copies of the Divina Commedia, by the way, including one incunabulus, and he had he writes in his book, okay, I integrated the parabola with the method of Archimedes, but then probably didn't remember about the book. And then he uses the method of the rectangles, that is the method of Newton. And it's funny, I mean, he got the method of Newton without thinking, and thinking that he found this in the book of Archimedes. Many people, I'm sure, that have a lot of books. I'm sure I'm a lover of books. I mean, I think a lot of people, also Rolando, is a lover of books, and this guy was a lover of books. So the problem of books is that when you become a bit older, you don't remember anymore where you read things and where is the book. So I have some, I don't know, I don't want to say how many books I have, but I mean, sometimes I buy the double books, sometimes I have to go to internet and find the book because I cannot find the book anymore, and things like this. But so it's incredible that with these 600 books, Galileo was making a mess. And okay. So the new language of mathematics at the time of Galileo was proposed first by Mersenne and then by Descartes. Descartes didn't like Galileo at all. He thought that he was a bad mathematician, which was maybe true. He was more ingenuous than formal. Okay, so this is the book of mathematics by Galileo. Okay, I'm going to finish this part, but I want to finish this part selecting some things about the different styles of Galileo. So Galileo invented the experimental method, invented the deductive method, and so on. But sometimes he was giving also some incredible demonstrations by just the a priori technique. The a priori technique that was used by the Docteur Parisien, the School of Paris, which was using just mathematics without a comparison with the reality. And one of my favorite demonstrations by Galileo is the demonstration of what is called now the equivalence principle, that you can enunciate in a simple way like the gravitational acceleration of all the bodies independent of the weight. This is done a priori, then confirmed by observation, not with the simple experiment that they made on the moon, but in a more sophisticated way that I don't have the time to describe. But okay, as I said, this can take a course. But so with a deductive method, Jean Buridan and especially Nicolas Oresme made a physics book, a physics that is synthesized in the book Le Livre du Ciel et du Monde, that you find in the Richelieu Library in Paris. That is, I think, one of the best two libraries that I saw. Richelieu is okay. And this is the book, by the way. It is a miniated code, so it is handwritten. So can you imagine just making this picture? Okay. And so Galilei, Oresme make a complete deductive demonstration that the fall speed depends on the weight. Now Galileo makes a deduction with the school of the Docteur Parisien, demonstrates the contrary. And I want to show you this demonstration that to me is fantastic. I mean, this is, to me, chicken shit demonstration. So it's suppose that the heavy stone falls with faster than a small stone. Then I connect the two stones with a straw. And I can say, okay, then I have a unique body which is heavier, so it will be faster. But since the straw can be as small as possible, I can say that the small stone will take behind the large stone. So if this is true, I can reach two contradictory conclusions, and this is absurd. So the fall should be independent of the mass. To me, this is, I mean, when you see genius, you have to say, okay, this is genius. Okay. So, and then he made an experimental verification. This was part of the game. Okay, how Galileo became an astronomer? So Galileo made a lot of experiments in Padua, and he didn't write anything. Actually, his demonstration about mechanics he did as the last book of his life. And he didn't publish in Italy, he published in Leiden. With Elsevier, that you know, is now a name that is quite known to scientists and not only. Okay, so somehow Galileo was brought to astronomy, that is probably one of the subjects about which is more known, by some events which appear just related to episodes. And sometimes our life is driven by episodes. And one episode is that when he received from an unknown mathematician, 26 years old, Johannes Kepler, a book. So Kepler sent him a book that was called Mysterium Cosmographicum. Kepler was graduated in Tübingen, and but not famous. He was a professor in Graz, and nobody knew that there was a university in Graz. So it was and then he thought, he wrote a book in which he said, I think I found the reason why the planets have the radius they have. So, what was the reason? There is there are only 5, it's not polygons, what is the name of in English of the polyhedrons. Polyhedrons, yes. There are only 5 polyhedrons that are similar to the regular polygons. So they have equal faces, they are completely symmetric by rotation along the axis. Only 5. This is a theorem by Plato, attributed to Plato. It's a very nice theorem also. And Kepler observed that if you put all the polyhedrons, one nested one into another, and you put some spheres around them, he said the radii of the planets are exactly what you get from this. Now you can see, of course it's wrong, I can tell you it's wrong, but you see immediately a guy who is not afraid of anything. Since thousands of years people were thinking why the planets have the radii that they are. Okay, first of all, he's Copernican. He doesn't think at all the Ptolemaic hypothesis. So the sun is in the center, you have the planets, voila. Okay, you see the ambition, a young guy who is not afraid of anything, and this helps a lot creativity. Second, you see that his measurements were not very precise. This also helps fantasy. If you're not very precise, when you become older, you start thinking more and more what you think is accurate. And this is a limit for science, of course. So this is the mystery that Kepler called the Mysterium Cosmographicum. But he didn't send this book only to Galileo. He sent it to the best scientists of the world. So he was so convinced of himself that he published at his expenses the book. And then he said, look, this is me. I'm 25 years old. I wrote this book. And this explains what people were looking for since a long time. Scientists have a different reactions. Some don't answer, but 2 people answer. One is Galileo, and one is Tycho Brahe, that was the best astronomer of the time. Galileo answers an incredible letter and says, I appreciate a lot of your work. He doesn't comment on the accuracy of the work. It means that probably he thinks it's wrong. But he says, you have a great talent. Go on. And I can tell you one thing. I'm also Copernican. This is the first time that Galileo tells that he's Copernican. He tells it to a 25 years old guy, unknown. Tycho Brahe, that then will become, after this letter, Kepler will go to Tycho Brahe to learn, ask him to become his assistant. We write, look, it's not quite good. It's good, but not enough. And he sends in the data of the planets, saying that more or less it works. You see here, the blue is the measured, and the red is what extrapolated, the hypothesis of Kepler. So it's not really true. And in mathematics, if it's not, if it is slightly false, it is false. Okay, funny story, but this also will have a consequence that Kepler will stop a bit and think, okay, maybe I have to work a bit more. Okay, another comment by an unknown physicist, that maybe it's me, but I don't know, because I lost the books, is that accuracy is the enemy of theory. The second episode that brings close Galileo to astronomy is the supernova of 1604. So in 1604, there is a supernova, a massive star exploding. By the way, there was a conjunction that night on 3 major planets that happens every 800 years. In the same night of the conjunction, the star appears there. So immediately people started speculating, like saying maybe the conjunction of the planets caused a concentration of energy that created this new light. But of course people said, oh, come on, this doesn't make sense because the planets look to us similar, but they are not in the similar place. They are very far away, just they are aligned, and so on. So people started interpreting the thing. Galileo was also an astrologer at the time. There are no signs that Galileo believed in astrology, but he was producing some horoscopes. For example, he produces for sure 2 famous horoscopes for his daughters, and he was selling horoscopes. Kepler was not believing that the stars were influencing our life, but he was believing that there was a correlation between the motion of stars and the evolution of humanity. It was somehow mediated by God. So, as a matter of fact, the astronomical event was very rare, and it was accompanied by this. And people started saying, okay, this is 1600, 800 years before, what happened? Charlemagne. In the year 800, you had Charlemagne. And then 800 years before, in the 0 year, what happened? Okay, in the year 0 year, we know what happened. Okay, and then they started saying, okay, this event is somehow special. The problem was that the church didn't didn't accept that there were the possibility that the fixed star sky was changing. So it was impossible for the church to believe that something beyond the moon, a new star beyond the moon, was born. So somehow this limited the effort of the scientists in Europe, because those related to the church could not investigate this topic. But Galileo did, and Kepler did. So in Padua, Galileo observed the new star. He measured the distance. He actually had a great idea, so he wrote to some colleagues in Spain and in Naples. He has to measure the position. He made a triangulation, and he could determine that it was much, much beyond Jupiter. So probably it was a star. And the point is that the University of Padua took a position. The position of the University of Padua was that this was an atmospheric phenomenon. So Galileo was somehow blocked by this position of the University of Padua. The position of the University of Padua was taken after some lectures by Galileo, and explicitly the book by Padua was saying that what the mathematician of Padua said was wrong. So the only solution of Galileo was to write a book in the Paduan dialect that is quite different from Italian. It was very difficult to understand in Rome, but I'm sure they read it, in which 2 farmers just discussed about the supernova, and they say, I must conclude that it is outside, that it is among the stars, because if I look to it from different places, I see it in the same place, so it's very far away. Okay, the book is very funny because the book is very funny. It's also very vulgar, by the way, but okay, it was written by 2 farmers, so nobody could complain. Also, Kepler saw the supernova. At those time, it was not anymore a young, promising scientist. He had done the right choice. He went to Prague he asked Tycho to become his assistant. Tycho made him wait 1 week. Kepler didn't have the money to stay 1 week, but he waited 1 week. And then in the end, he admitted it. And after Tycho died, he designed as his successor in this chair, Kepler. Okay. Even if also the husband of his daughter was among his assistants, he preferred Kepler. He understood that Kepler was the right guy. Okay, Kepler will make detailed studies of the supernova. Kepler, different at variance with Galileo, was writing very little. Kepler was writing a lot. Kepler was writing a book every year, and he was writing basically what he thought. So the book, if you read the book about the new star by Kepler, he talks about a lot about the price of the wine and so on. Kepler and Galileo shared the passion for wine. So he talks a lot about this, and for example, in another book he writes, he was a widower, and then he wrote how to find a wife. So he was making some Excel table, like how pleasant she is, how rich she is, how well she cooks, and so. So you were making a competition on the possible wife. So in the end, he made how to choose a wife. So, okay. The values of Kepler were, Kepler had a lot of children. Okay, so Galileo receives also the book by Kepler, which is much superior to the book by Galileo, but also Galileo was limited by the fact that the church had an official position, and the University of Padua was taking the position of the church. Okay, as a matter of fact, the last supernova is called today the Kepler supernova. In 1609, Kepler writes his book, this famous book, Astronomia Nova, in which he tells the first two laws of planetary motion, the elliptical motion and so on. And he revolutionizes, he makes a revolution in astronomy. Galileo receives the books and he annotates it very carefully. But Galileo is doing something else. Galileo received from Paolo Sarpi, who comes back from Holland, the drawings and maybe a prototype of the telescope. The telescope was not working very well. Galileo writes in his notes that it is does anybody understand bad words in Italian? 1, 2? The others no? Then I can use it? Okay. Galileo wrote it was una coglioneria. Yes. He writes that the telescope is a coglioneria. But he worked with the Venetian glass crafters to improve it. Venice was one of 2 towns which had at that time the technique of lead glass, crystal. And with doping glass with lead, you can change the refractive index and make better lenses. So Galileo worked with a chemist and for more than 1 year, and he transformed the instrument into an astronomical instrument. And he will make in the end 400 telescopes, and we have 2 left. They are both in Florence. And then he starts observing. The first observation of the moon, and when he observes, he makes some drawings by wash. Galileo was a good painter. So these are the famous drawings of the moon. By the way, a curiosity here for librarians. This is a curiosity I like for the guys, the brothers, because I know the guy. Okay, Galileo could measure the height of the mountains of the moon. He said the mountains of the moon are at least 10 kilometers high from the position of the shadow. Okay, he observed the fact that the Milky Way was not a fog or a milky structure, but it was made mostly of stars. These are the Pleiades drawn by Galileo, in which the 6 Pleiades are superimposed to the stars that he sees with his telescope. He saw the moons of Jupiter, that is to him the best discovery of the book, day after day in Padua from in January 1610, compatible with the fact that the weather in Padua in general is foggy and so many nights you couldn't see. So he saw that the satellites are revolving very fast with 1.6, 3.2, 1.8, 3.6, 7.2, and 16 days. Why this funny ratio? 1, 2, 3, 1, 2, 4, almost 8. This will be discovered 2 centuries later. But Galileo thought, why this? There must be something. Okay, so every night he saw 2 eclipses. Every night the sky is changing. By the way, also Newton will make a comment about this. Then, okay, he published the book. Before publishing the book, after he sent the manuscript of the book and before the publication, he discovered Saturn. He didn't understand that Saturn had some rings. He thought it had 2 satellites. And then he told it to Rubens, because the 2 were meeting. Rubens was speaking Italian very well, because he was working mostly in Mantova and going frequently to Venice. And so Rubens made this painting in El Prado, the Saturn by Rubens, with a vision of Saturn that was told to him by Galileo, and that Galileo withdrew 5 years later, because 5 years later he built a better telescope and he made this drawing. This is one of the 200 notebooks by Galileo in Biblioteca Nazionale Centrale of Italy in Florence. And you see, compared to a finger, it's just a small note that he discovered the rings of Saturn that he didn't publish. Strange. Okay. Okay, so finally, without Saturn, but with all other discovery, Galileo writes a book that is at the same level, at better and better than the book by Kepler. It is called Sidereus Nuncius, that means a message from the stars, or the messages of the stars. The title is ambiguous. And the book is, the book is overwhelming, because Kepler is precise, Galileo is an instrument, and the instrument sometimes makes a difference. For the librarians, I want to talk about a nice, no, not nice story, but Galileo printed 550 copies of his book, which sold like hotcakes. In 2 weeks, they sold the copies. And he asked the publisher to keep 5 copies without the figures, because he was not satisfied with the woodcut that he supervised. So but he was a real perfection. By the way, also Kepler was not satisfied with the woodcut. So these people were maniac, perfectionists. Now we say, okay, the editor did this, but let's. And so apparently it is possible that there are 5 copies of the book with some wash by Galileo instead of the paper cut, and this would be incredibly precious. In the year 2005, 20 years ago, Massimo De Caro, that is a guy that I know, claimed to have discovered in Buenos Aires one of the 5 copies. And the copy was sent to the director of Max Planck Institutes for the history of physics, who worked with the Max Planck director for nuclear physics, to the professor of history of science and previously of astronomy in Harvard. So they made a committee who said, this is the original book by Galileo. But it was not true. So the guy was, I have a friend of mine that is the other expert of Galileo made a radio emission about the history of De Caro, to which De Caro participated, by the way. The funny thing is that De Caro participated to this podcast. Okay, how the story of this fake, that there's some aspects which are just crazy. The guy was crazy. By the way, he was condemned to 7 years of jail. In Italy, it is difficult to get 7 years of jail. You can do awful things. If you beat an old woman on the road, I think they don't give 7 years. But for this crime, the guy got 7 years. Okay. So Galileo immediately sends the book to Kepler. The book is transported by Thomas Saget, a friend of Galileo, a librarian. And Saget had an album called album Amicorum. In Italy, it's very common that the daughters, the teenagers, female, they have a book in which the friends of them sign a page, make a drawing and say, I will be your friend for all the life. I don't know if here it is common, but in Italy it's very common, yes. So this guy, this Thomas Saget, had this book. Normally for boys in Italy it's not very common, but Thomas had this book, and so you see here the book by, the drawing by Ortelius, which is a famous cartographer of the time, and the drawing by Galileo. And then the text say, okay, we'll be friends forever, and things like this. Okay, so Saget says, I go personally to Kepler because I want a signature on my book. And okay, Kepler is impressed by the book. He say, okay, I need 1 week to write a letter to Galileo, and then you will write even a better letter in which you say, okay, now we should work to space cartography. And then he makes another gift, that is Galileo had observed in his Sidereus Nuncius the phases of Venus, and Kepler observes that the phases of Venus are a demonstration that the Copernican system were supporting the Copernican system, and certainly they were not compatible with the Ptolemaic system. The Tychonian system, okay, don't want to spend hours on this. Okay, Galileo then moves to Firenze. I am 6 minutes late, but I will go to the end now. Okay. Okay, as you know, the fact that Galileo goes to Florence is somehow the end of his, not the end of his career, because he will make the 2 best books, two out of 3, when in Florence, but it is the end of his freedom and the beginning of his problems in life. I move just to conclusions, and here are some books that I wrote on these stories that I told you now, but the ones in English, you can find them for free. You can download them for free from the Springer site. So I'm not trying to sell books, but I just wanted to emphasize, to select some subjects to emphasize that the fact that Galileo was Galileo, Kepler was Kepler, and so on, was due to the fact that they live in a period of revolution, of scientific revolution, which helps a lot. Main changes, but also connection, cooperation, and competition, as you said, between different countries, different civilizations. What is funny to me nowadays is that, for example, the supernova of 1604 was also observed by Arabs and by Chinese, and they didn't know about this observation. And now we can compare the observation, and this is an emotion to me to see that people that I didn't know, they were seeing the same thing and commenting. Thank you.
Now we'll take questions.
Hello, I have a question for you about Galileo, the fine arts and observation. I know that Galileo had an interest in the fine arts, and he wrote on the famous question of which was the better art form, sculpture or painting. And he came down on the side of painting, because painting was able to represent a three-dimensional world on a two-dimensional surface, had all kinds of perceptual tools to do that, like modeling, perspective, and so on. And you showed his sketches of the moon, and those seem to me pretty good examples of someone who understands the difficulties of making the move from a three-dimensional world to a two-dimensional surface. So I wonder if you could say a bit about Galileo and the arts, and whether they had any influence on the way he proceeded.
Galileo's interest for painting was accompanied by natural talent. So before studying painting, Galileo was already drawing very well. So I don't have here, it's a pity, but I don't have here some drawing that he did of the Lagoon of Venice, some watercolor, which are, to me, unbelievably nice. So he made these drawings before studying. Then after going to Florence, he made some workshop in Rome, I think at Carracci's, and so he could become really a kind of professional. And from time to time in his logbooks, he makes some drawings. What is funny, that people don't emphasize, is that these drawings can be whatever. And when I say whatever, I mean whatever. You know what I mean. There are some people, as you know, that think that Galileo met. I'm becoming old. I mean, tell me a nice painter that made San Lorenzo dei Francesi in Rome. Caravaggio, yes. So you see, sometimes but I do it. I'm sorry, but for my memory, sometimes I call my daughter with the name of my sister. My daughter gets upset awfully. I know that it is my daughter, but okay. So some people say that Galileo met Caravaggio, but there is no proof of it. Okay.
At the end, you mentioned that the Chinese and the Arabs had made the same conclusions. Did I misunderstand you or not?
No, it is true.
Okay, now I would like to know, because I missed something there. They didn't write anything. Did they know about each other's...
No, I mean, the Chinese, the Koreans.
I'm sorry, if you could use microphone because people are watching online and they won't hear.
Yes. Sorry, the Chinese, the Koreans, and the Arabs made some observations of the supernova. Galileo and Kepler didn't know about them, or at least they didn't write anything about this. I must say that the only accurate ones were by the Chinese. The Arabian ones were quite qualitative. I mean, the top was Kepler. Kepler was fantastic, but he was a student of Tycho Brahe, which was the best astronomer, probably. No, I don't want to say ever, but he was incomparable. And but the Chinese were quite at the same level as us. But yes, no, the same. 1604, they saw the same supernova, and we still can reconstruct the light curve of the supernova, because when you have a supernova, it does. I mean, first it explodes, then in 2 days it gets the maximum, then slowly go down, and this has a lot of information for physics. So we can get, by folding the information by the Chinese, Kepler and Galileo, we can still make some physical papers. So the Chinese were more or less at the same level. A funny thing to me, I belong to a generation in which you are doing science also because of pride. You wanted to say, I am the first one who does this. Now young people are no more like this, fortunately. The Chinese astronomer doesn't sign himself. Funny. In Italy, I mean, Kepler was saying, why me? Why Kepler?
Thank you, Professor. Just a very simple question. You have mentioned the fact that Arab scholars have, how can I say, have seen and have studied the same phenomena that Galileo and Kepler were observing at the time. I know that it couldn't have been possible with the Chinese and the Koreans. But do you have documentation on contacts between the Arab scholars and the Galileo or Kepler on these specific subjects, or on astronomy in general?
No, I don't have documentation of any contact, and it's not likely that there was contact. But Galileo was studying also on Arab texts. I mean, this is many astronomers are studying on Arab texts. Most of Ptolemy is left on translation from Arab. Many Greek books went lost, and they survived thanks to Arab translation. And then you don't know anymore what is the contribution of the original author and what is the original contribution of the translator, because sometimes people were just attributing their work to somebody else, like Oresme said that he was translating work by Aristotle, but it was not true. Just to have more authority, like the book by Kepler, the book on the laws of planetary motion, he says, I present you some notes by my maestro Tycho Brahe, but it was not true. Is it me?
I think it's your.
Online. No, must be online. But it was Italian. So it's some Italian watching. Okay.
When I was looking through one of Leonardo's notebooks, he makes a comment about what he basically had there was he had a number of spears, and he was demonstrating basically ways of ejecting spears into the air, and had a number of various straps and things.
Sorry, I don't hear.
Oh, basically he had spears that he had drawn. Spears, like spears to throw.
Yes.
Spears, lancia. Yes. So basically what he was doing was he was wondering how best to throw these spears. Yes. And then he makes a comment, and I need to talk to Piero Monte. And so one of the questions was, who was this Piero Monte that he had to talk to related to the throwing of spears? So I began to look into this a little bit, and other people have too. And one of the things about Piero Monte was that he was a Spaniard. He appeared to be an expert in fencing and many other things related to that. And the issue was that Piero Monte had already looked at the issue of Archimedes and the falling of objects. And he had come up to the same idea that no matter what the weight was, they would fall at the same sort of time. And so one of the questions I have is that, he did write a large book associated with some of his work. There's sort of information that he indeed knew about this idea, and it was a very active time period in Leonardo's life, so he probably may have known about this idea. And probably because Piero Monte had already done this, Leonardo really didn't think it was an important thing to do because it had already been proven. So we already have a century and a half later that Galileo is doing this. So you sort of wonder sometimes about whether or not knowledge occurs instantly like that, or whether it sort of percolates through time and other people hear about these particular ideas later on. So it's just an interesting sort of observation.
It's interesting. It is that I didn't know that I would study. Yeah.
Good.
Thank you. When you learn something, I'm very happy. Thank you.
Have one quick question. Probably it's not that quick to answer it. You mentioned that Abraham Ortelius was in contact with Galileo Galilei. So they were not? Oh, okay. Because my question was about what was the extent of their collaboration, if they ever collaborated to create maps, whether of the celestial sphere or not. Because Abraham Ortelius, he did the Teatro Orbis Terrarum, and I was curious if Galileo Galilei had any input in that.
Okay, first of all, I don't know if Ortelius had contact with Galileo. Ortelius had contact with the librarian of Galileo, because Padua had one big library that was the Pinelli Library. That then was, and the librarian of Pinelli was Thomas Saget. So Thomas Saget knew Ortelius, who made this fantastic drawing for his album of the Friends, but I have no demonstration there was contact with Galileo, between Galileo and Ortelius. By the way, the library of Padua, the library of of Pinelli, that was the library in which Galileo was studying. After the death of Pinelli, was sold to Naples. It was transported by boat, and it took 4 boats to transport the library. One boat was sunk, so we lost 1/4 of the books. Then the books arrived in Naples. Pinelli was from Naples. And then the family of Pinelli sold it to Milan. And then it became the kernel of the Biblioteca Ambrosiana, one of the national libraries of Italy. And somehow, if they could have sent immediately the books from Padua to Milan, probably the Pinelli collection would have been conserved. So sometimes the story of books is very sad. Okay. There was a question there also. My own background. My own background is quite common for an Italian of my age. So I studied at a priest. I made classical school. Then I went to university and made scientific studies. Now it's less common for young people because they are more specialized. Then I went to CERN Geneva to a laboratory of high energy physics, particle physics. I stayed there till the year 2000 as a researcher. Then I was offered the professorship in Italy. I came back to Italy and I decided to do astrophysics. And now I'm not anymore good as an astrophysicist, but I like a lot. I'm doing my hobby, that is history of, especially of the Renaissance period in science. So I'm narrow time, and I'm learning, but I'm not a professional historian. And this is evident from my way of telling things.
Yes, thank you very much for the talk. I found it fascinating the way you described the relationship Galileo had between induction and deduction.
Yes.
Yet it seems that in his own science he refused to accept some of the observations that were made by Kepler about elliptical versus perfectly circular orbits, or about the tides and the way in which gravitation could influence the tides. So why was he so reluctant to accept empirical information, yet he was clearly a very empirical scientist?
It is okay, with my Canadian friend Bill Shea, that I hope you invite Bill, because Bill has a culture that is overwhelming to me. Sometimes we make the game of Galileo and an opponent of Galileo. So normally say, I want to be Galileo. No, this time it's me, last time it was you. Okay, it is difficult to understand how Galileo was thinking. It is clear that sometimes he neglects some basic information. Of course, nobody of us, neither Bill nor me, nor is comparable as a scientist to Galileo. But it is clear that he was filtering information, so reaching his conclusions, ignoring part of the information. How could he select to ignore things that were not destroying the validity of his conclusions? We don't know this. It is difficult to enter in the mind of a genius. Sometimes he was even wrong, because, for example, the fact of neglecting the ellipticity was quite... because Kepler discovered the ellipticity in the beginning of the 17th century, and he wrote about this to Galileo. But Galileo ignored this. And Kepler said that there must be an etiology. He wrote etiologica, blah, 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 in this. And Galileo could have understood this, but he didn't. So Kepler was wondering about the etiology of this anomaly, and Galileo neglected it. I don't know why, but it is true. He neglected some information. Nevertheless, I think we would all like to have a scientific production like Galileo. Okay, true.
I
would just like your thoughts on the trial of Galileo. What would you think about Galileo at the trial and the fact that he actually did not? Well, I'll let you to talk about what you thought. Oh, what your assessment would be of the way that Galileo was associated with the trial.
Okay, this is another topic. This topic I like a lot because I'm giving you a list of people to invite if you want. And I had a professor of mine, so a guy, must be in the 90s now, who was a lawyer in the revision of the trial of Galileo. You know that the Galileo trial was reviewed by Pope Giovanni Paolo II, and somehow with an ambiguous result. Okay, so my professor, and now I can say friend, is very Catholic. I'm not. So the point that the Catholics are making is the following. Galileo could not prove that the Ptolemaic system is wrong. He doesn't have any proof that the Earth is rotating. So, since his argument was just a simplicity of the equations of motion, assuming the Copernican system, he was not authorized to privilege the simplicity of mathematics to the word of God. In this sense, Galileo was wrong in affirming the Copernican system in the absence of proofs. This is the argument that is still valid from the point of view of the Church, that I can understand. I studied at the priest, as I told you, so I can understand an argument like this. Of course, I don't agree, but I understand the argument. So, Galileo was somehow condemned for a position that was shared by almost all the scientists of the time. Because at that time, there was no more Ptolemaic scientists. You had the real scientists were either Tychonian or Copernican. And it was just probably a point of affirmation of the Church of its power, because there was no real point. They didn't ask even scientists from the Catholic universities. Rome had two big universities, La Sapienza and Collegium Romanum. But nobody of the priests of the two big universities was intervening in the process. So I think it was just an affirmation of power. By the way, if you go to Florence to the home arrest house of Galileo, did you ever go? At my age, I could accept home arrest in this place because it's a fantastic villa with a vineyard, he was close to his daughter, so it was not a bad, I could stay there. Sometimes you get permission to go out to Florence. Anyway, it was clearly from the point of view of the affirmation of the power of our church and the influence of the church on science. It was the church made a strong point because he was the most popular scientist of the world. Milton went to visit him, and a lot of people were surprised by this condemnation.
Do you think it was just the fact of his family, the money he needed for his daughters in in the various types of nunneries, etc., that he decided that it was best not to sort of go against them completely? Or do you think that he just decided that there was no way he could win and therefore why bother sort of idea?
I think he didn't care at all, so it was better to simplify his life and to make abjura. In the end, he was humble, and humility is an expression of extreme arrogance. I don't care. Thank you to you. Thank you to you.